Let me introduce Dr. Phil DiStefano, who is Chancellor at the University of Colorado Boulder. Prior to his appointment in May 2009, Dr. DiStefano was a top academic officer at CU Boulder for 8 years as the Provost and Executive Vice Chancellor for Academic Affairs. Dr. DiStefano is on the Collaboratories Authority Board, as I mentioned this morning. And so let me welcome Dr. DiStefano. Don't you hate it?
Thank you, and good afternoon to everyone. And I want to personally welcome you to the University of Colorado Boulder and the Sustainability, Environment, and Energy Complex that we call SEEK. SEEK and the people working, teaching, and learning inside and outside of it represent our commitment to research and education in sustainability, energy, and the environment. And this is home to 1,000 environmental study students who are pursuing the same important goals that you are. The work that goes on here furthers our partnerships with federal labs and agencies and Colorado's research universities that share a goal to develop and transfer clean, renewable energy for the benefit of all. And we highly value our Colorado Energy Research Collaboratory partners with NREL, Colorado State University, and the Colorado School of Mines. And we're also pleased to have both Governor John Hickenlooper and former Governor Bill Ritter participating in this important summit today. And I'd also like to thank our good friend Paul Johnson, President of Colorado School of Mines, for joining us. And also allow me to acknowledge Terry Fees, our Vice Chancellor for Research and Innovation, and also Bob McGrath, Director of the Renewable and Sustainable Energy Institute, RACI, which is a partnership of NREL and CU Boulder. And perhaps no one knows this better, that developing clean energy and transferring it to market requires a multidisciplinary and multi-institutional approach than our keynote speaker, Dr. Lynn Orr, and I have the pleasure of introducing to him. Dr. Orr was sworn in as the Undersecretary for Science and Energy in 2014. As the Undersecretary in the U.S. Department of Energy, Lynn is the Principal Advisor to the Secretary and Deputy Secretary on clean energy technologies, science, and the research initiatives. Lynn is the inaugural Undersecretary for this office. He oversees DOE offices of electricity delivery, renewable energy, fossil energy, Indian energy policy, and nuclear energy. Please join me in welcoming Dr. Franklin Lynn Orr. Lynn?
Well, good afternoon. It's great to be here. We have a big assignment ahead of us, and there is rumored to be a clicker here somewhere, but I don't see it, so we'll have to, it's coming. So this is the part where I dance for a little while until it's here. No, actually, I don't need it to get started and there we go. That's the slide I wanted. Thank you very much. Great. So why are we here? We're here because the future of the United States depends on our ability to provide economic security, to take care of the environment and indeed the whole planet's environment in a way that sustains us all and that provides secure access to energy. And you know, that's any one of us in this room probably could have made that same statement. But it's worth reminding ourselves once in a while that energy is so woven through the entirety of modern societies that the way we supply it and use it, it matters fundamentally to our economies, and it matters fundamentally to the health of all of us and the planet going forward. So I thought, you know, once in a while, it's useful to step back and remember, why are we trying to do this? So here comes a lightning review of the current data with regard to climate and energy. So you've all seen this temperature plot many times. if your eyes are good, in the upper right-hand corner there, you can see this went to October 2015, so you can see the one data point that's a little higher there, but the trend is truly unmistakable. Now you'll notice in what I'm about to say, there's not going to be any simulations. This is all observation. And you can ask, well, okay, is climate changing, and how could we see that in other ways? So if you live in a particular place on the planet, then there's a distribution of temperatures at that place. And so we can compare those over time. This is, of course, where the mean is different wherever you are. So so this is northern hemisphere on the top row, southern, and that's summer in the top. And the bottom row is northern hemisphere winter temperature anomalies. The left one is the standard we're comparing with, 1951 to 1980. And as you can see, the decades slide to the right. So do the means, and particularly there are big changes in the extremes of the distribution shifts to the right. So warmer temperatures in both winter and summer. There has been various bits of complaining about how temperatures haven't changed over some period. In order to make that claim, you have to be willing to take a short enough period. But it's worth noting that there's a big difference between El Niños and La Niñas. The El Niños are red here, and the La Niñas are blue, and the gray ones are kind of the neutral phase. So what's going on with the circulations in the ocean and the warm water sloshing back and forth in the Pacific turns out to matter in planetary average temperatures, but the trend is pretty clear. If you try to measure how much of that thermal energy is stored in the upper part of the ocean, you can see these data here. The different curves reflect different ways to average, but nevertheless, the trend is also clear that that thermal energy that's being acquired because of the greenhouse gases in the atmosphere is being stored in the ocean. It's a big system, so it takes time to modify that big system. We can also measure the pH of the ocean. As CO2 dissolves in the ocean, it lowers the pH. And just for those of us who have spent our time working on CO2 capture and storage, the ocean stores 24 million tons a day of CO2 from the atmosphere. So big quantities of CO2 end up in the ocean. And when they do, they reduce the pH. Reducing the pH changes the balance of carbonate and bicarbonate ions, makes it harder for all those little critters that fix calcium carbonate to do their jobs. And a bunch of those are sitting at the bottom of the food chain. So you can imagine that there's a potential for impact there. Sea level rise comes from both thermal expansion of the water in the ocean. It's not very much, but there's a lot of it. And of course, for ice that's not floating as that melts, that finds its way into the ocean. Again, the trend is pretty clear, and there are consistent data from tide data and gauges and satellites. And then there's ice. Governor Hickenlooper mentioned that the ice cover is low. Now, ice depends a lot on how cloudy it is in the Arctic and how much the way the wind blows that moves the ice around. But there has been a big trend toward, you can see the bottom graph on the right shows the trend downward in Arctic ice sea extent from 79 to 2016, and the 2016 curve, it's not going to beat the 2012 low point, but it's going to be pretty close down there. So again, no real question there. So you say, okay, I'm convinced. The data keep piling up, and will continue to do so. And maybe that will help us increase our resolve to do something about this. So let's talk about how we might do that. So I wanted to say a word about the Mission Innovation Challenge. Most of you know that the United States and China issued in 2014 substantial commitments to reduce greenhouse gas emissions on their own parts, and that was not an agreement. That was parallel announcements by the presidents of the two countries. They were different in format, but what they did was to set the stage for the Paris negotiation that made it possible to do some things there that I think really were much harder to do before. One, the two biggest emitting countries were willing to put forward substantial commitments. And two, the structure of the negotiation this time was to invite countries to make what were then called INDCs, intended nationally determined contributions. They've since then gone beyond intended, and many of them have issued their nationally determined commitments. And so that, instead of trying to negotiate who was going to do what, nations showed up and made their own commitments in terms of what they were willing to do. So the agreement was concluded and signed, and that is now in the stage of sort of ratification by the various countries. The accord will take place when 55 countries that represent at least 55% of global emissions have joined. So far, 27 countries, including China and the United States, have joined, and that's 39% of global emissions. So this week, of course, is the UN General Assembly meeting in New York. And I know there has been and will be lots of behind-the-scenes discussion. There's some hope that we might actually see this get done by the end of this year, which would be a real accomplishment and much faster than the conventional timing for all those individual governments to go through the approval processes that they have themselves. So some significant, I think, progress there. Now, if you asked the modelers, well, do the nationally determined contributions get us where we need to go? And the answer is it's a very big, important step along the way, but it kind of gets us halfway there. So I think that comes back to one of the questions that the first panel dealt with, which was, do we have all the tools we need? Can't we just go ahead and do this? And I think the answer is, Martin Keller did a good job of saying we need to use the tools we have now, plus some more that we need to invent. And the reason we're gathered here today is to think about how to build the invention side, even as we work as hard as we can on the deployment side and on the energy efficiency side, because all of those things help buy us time to deal with the other things that we need to do along the way. Then at the beginning of the Paris meeting, there was a commitment made by the U.S. and 19 other world leaders to seek a doubling of the public investment energy R&D, clean energy R&D over the next 5-year period. That grew out of a series of discussions amongst international leaders. Secretary Moniz was very much involved in that with the combination of sort of the country leaders and particularly their energy ministers. I think as we entered the spring of that year, we thought, maybe we'd get half a dozen if we were lucky. But by the time the meeting started, we had 20 countries that were willing to step up, and there are several more. The EU has since joined, and there are a couple more that are working on this now. So these represent around 3/4 of the CO2 emissions from electricity, and also more than 80% of the clean energy investment that's out there now. So if all of the countries can pull this off, then this amounts to a significant improvement and a significant increase in the funding. So we, of course, are busy thinking about what that would mean for the U.S. Our total, in the big broad terms, the worldwide investment is kind of $10 billion a year. We're perhaps just under half that, maybe 4.8. Mostly in the Department of Energy, but not exclusively. We're probably 3/4 of the energy R&D, but NSF, DOD, Interior, those agencies also contribute in a big way. And so we're all working as hard as we can, both to think about how we would deploy the additional resources if they're available, and how to make sure we do that in an as efficient way as possible. So you say, okay, great, what do we do? Well, obviously, I say obviously, it's obvious to me. So my job at DOE includes the fundamental science side. So that's about half of the science and energy budget. And that supports 10 of the 17 national labs, the big science user facilities, basic energy sciences, nuclear physics, high energy physics. These programs, and of course all the advanced computing. So these fundamental science programs provide an absolutely critically important fundamental underpinning of science for the future. Some of it is discovery science, some of it has direct applications, but in every case we're really trying to build the fundamental science that's important here. The other half of my domain is the energy R&D. It includes energy efficiency and renewable energy, fossil energy, nuclear energy, the Office of Electricity, which worries about the grid. These are challenges that, these are all the places where we work to do the next stage of energy R&D. And I think the most important point I can make here is that we need to work across that full portfolio. We need the fundamental underpinnings and we need the applications, and we should stock that portfolio across primary energy resources and the ways we transform those into energy services and across various time frames, with plenty of attention to energy efficiency in every aspect of it as well. So that's fundamental. The other thing I would say is that we need to look for the opportunities to do collaborations. I thought the Governor Hickenlooper set me up perfectly for what I want to say next by talking about the collaborations possible here in this area. And I know that this is, and Governor Ritter, of course, has been actively engaging in collaboration, so he's evidently on board with this as well. So let me tell you a little bit about the experimental work we've done at DOE in this regard. And we have been doing some experimentation. You know, we're probably, particularly on the science side, we're probably most thought about as supporting individual investigators and their research groups. But of course, we've also supported for a long time the big user facilities, the advanced light sources, the Environmental Molecular Sciences Lab at Pacific Northwest Lab, the kinds of things that bring scientists together to work, especially when they need facilities that are too expensive for an individual university. But we've also been experimenting with some other approaches. So let me just mention a few of those. One is Energy Frontier Research Centers. There are 42, I believe, of these active at the moment. They have over 100 participating institutions located in 33 states, plus the District of Columbia. They typically run $2 to $4 million a year. There'll be some lead institution. It could be a national lab. It could be a university, a bunch of collaborators. But they if you look at the topics, they bring together researchers, national lab, faculty members in interesting ways to work on some focused problem that requires significant effort in the fundamental sciences. So just to mention a few, these were of course randomly chosen from the list, but they all happen to be in states that are near here, so maybe it wasn't entirely random. There, and I'll let you read. But these, they range from material science to better solar to catalysis. You could argue, I think, that catalysis is widely distributed across the energy arenas, but batteries and kind of any kind of electrochemical or chemical manufacturing setting is a place where catalysis matters. And the idea of being able to use solar photons or electrons in general to do catalytic things is widely pervasive in future energy technologies. So the Energy Frontier Research Centers are one thing that we've tried to do. And as if we are able to expand the energy R&D effort under the Mission Innovation rubric, we will certainly increase the support for Energy Frontier Research Centers. At a somewhat larger scale, we've experimented with energy innovation hubs. There are a smaller number of these because they tend to be $15 to $25 million a year. They tend to be much more focused on something. So there's a Critical Materials Institute led by Ames National Laboratory. We have a new one proposed for an energy water nexus. There's a group led by Oak Ridge, but with collaborators that looks at very detailed modeling and numerical simulation of nuclear reactors. There's an Argonne National Lab project that looks at batteries and energy storage, and then a UC Berkeley Caltech collaboration that's looking at solar fuels broadly construed, so taking solar electrons, making hydrogen, or reducing CO2. So that's another version of this experimental effort. At kind of the other end of the spectrum, on the manufacturing side, there's been a series of efforts on the advanced manufacturing side of things. These range from something that might involve, so for example, the additive manufacturing area, the idea that instead of taking a big chunk of metal and machining away the parts you don't want, you start with a powder of the same metal, 3D print it, spray it into position, and use electron beam melting or some other technique to fuse it together. It requires less energy to make the part. The parts you can make shapes that are hard to do by machining, so you can make lighter weight parts that do the same thing. So it's good from the manufacturing side, it's good from the cost side, and it's good from the energy use side. If it's a part you're putting in an airplane, how much that thing weighs determines how much fuel you have to use to carry it around. So there are a variety of these things that involve wide bandgap semiconductors and so on, advanced composites. So, and then there's ARPA-E. ARPA-E has they have a format that the rest of us at DOE are wildly jealous of. And that is that they get their pot of money and then they get to decide how to spend it. I can tell you that's not true for the other part of DOE. There's budgets and Office of Management budget and the Congress, and there's lots of players that get into that stage of the game. But ARPA-E is aimed at doing the kind of proof of concept, early stage, what would it take to get this technology to market? And they pay attention both to the thermodynamics. I mean, they try not to do projects that violate the second law, but they do think about, how could this transition to the marketplace at the same time they're working on doing the proof of concept and demonstration. It's been very successful. There have been, the latest count I heard, I think, is 36 new companies and 10 or so new products on the energy market. the question you would ask is, well, are there more ideas out there than they can fund, or are they funding all the good ones? And the answer is that if you look at their proposal process, the success rate from front to back is about 2%. So I know from having been a reviewer before I had my current job, that there are good proposals that are being left on the table there because we don't have as much money as we could deploy successfully. So you say, okay, well then how could we add to this? And the one way that we think we could add to this is through regional clean energy innovation partnerships, and that's the topic that all of us are kind of thinking about here today. And I'll get to the rationale for this in just a minute, but we're really looking to take advantage of the expertise that's distributed around the country at the combinations of organizations, universities, national labs, nonprofits, and industry that have to go together to take any idea and go from some glimmer in some lab rat's eye to something that actually changes the world's energy systems. Now, we proposed $110 million in the FY17 budget to support getting these kinds of things started. You might have noticed, sometimes people outside Washington notice, that the Congress has not yet passed a budget. And in fact, their assignment between now and September 30th is either to pass a budget, don't hold your breath on that one, or a continuing resolution that will allow all of us to come to work while that other event for November takes place and the Congress comes back after that. So that hasn't happened yet, but as I said, that's job number one for the next couple of weeks in Washington for the Congress anyway. But we do have some indications. Both the House and the Senate have some versions of the budget out there that give us some idea of what the individual parts might look like. We didn't. The Senate budget bill has some very good language with regard to this idea of working on regional efforts. I'll let you read that, so I don't read it to you, but there's good language. We'll see how we get on the actual dollars as that flows out. If you look back a little farther, the National Research Council's 2012 report called Rising to the Challenge said, federally R&D in general hasn't really been as connected to the state regional innovation ecosystems as it could be, and that there would be real benefits to capitalizing on the combinations of intellectual capability and regional assets that could make us all this work better. So, and the idea that there are such ecosystems, I think, is experimentally demonstrated. You look around Silicon Valley, the Boston Route 28 kind of Route 128 area, Chicago, and no doubt others. There are plenty of opportunities to capitalize more effectively. And you say, well, okay, so there's regional asset regions, but there's also regional resource regions to think about this. And all you have to do, for example, is to look at, for example, these numbers with regard to how much water it takes with the generation systems to deal with, to generate a megawatt hour of electricity. And your eyes would probably have to be pretty good to to see the actual numbers, but I can say that they just vary hugely from place to place. In the Northeast, maybe almost 20,000 gallons per megawatt hour. In the Southwest, 9,000 gallons per megawatt hour. In Alaska and the Arctic, 3,000 gallons per megawatt hour. So big differences, and of course, 40% of the energy, 40% of the water, freshwater withdrawals from rivers and lakes and streams in this country go to thermoelectric power generation. So water is an important component of the generation side. And then, of course, the point was made in the panel earlier that it takes electricity to move all that water around. And so these systems are deeply interconnected. And I would say that some of you might have run across the quadrennial technology review that the Department of Energy issued about a year ago. And what that recognized, in addition to the specific application here, was that there were real systems opportunities across the board in the energy system. So you can think about the water distribution system, the fuels distribution system, and the grid. These are all complex systems that deliver services, but they're linked and overlapping, and they also connect to climate. So we should be thinking about how to manage and make more efficient the systems, in addition to thinking about the efficiency of the individual components. So that's there's an opportunity there as well. If you look at renewable resources, there we go. Whoop. Well, on my slide here, there's a nice map. There it is. Maybe I must have hit the. That's what happens when you steal slides from one presentation to another, you know, and bad things happen on the sequencing. And again, your eyes would have to be good, but green is biomass, wind is blue, concentrating solar thermal is red, and photovoltaics is yellow. And you can see that there, if you kind of step back and fuzz your eyes, you can see that there are broad swaths where there are bigger kinds of resources for one than another. And that, and if you looked at the way the grid was laid out too, and the regional balancing areas, you'd see that those differ as well. So there really is an opportunity, we think, to take advantage both of the resource side and of the intellectual capacity side in a way that will make the sum of the whole be the sum be more than the sum of the parts. So that's another rationale here. If you look at the regional locations of big sources of CO2, along with, as I recall, this is U.S. CO2 sources within 50 miles of a saline aquifer or enhanced oil recovery or a CO2 pipeline that already exists. So there are some opportunities here as well and they're different regionally for sure. So I think there's plenty of reason to think about what might be done regionally. So what kind of things would we be talking about? Well, we want these regions to be big enough that they bring together lots of assets. We're imagining a nonprofit that forms up to be a sort of research administrator, not a research doer, although the organizations that band together as part of that nonprofit would certainly be permitted with a reasonable conflict of interest provisions to be research performers. And they would have broad latitude to set the priorities across clean energy technologies and based on the regional needs and the opportunities and the R&D capabilities in the region. And the idea would be that we would provide an annual funding stream based on annual plans, and that we would expect these to network across lots of kinds of entities. The kinds of things they might do would be to obviously support R&D through grants and contracts, maybe support regional competitions or prizes, offer some way to help attract patient capital, recognizing that the energy system is big enough that it doesn't happen overnight, that we all decide we have to have a new energy provider the way we might all decide we have to have a new cell phone. And provide some data and analysis, some tracking, and connect up to the educational and job training side of things as well, and then look at ways to support the startup communities. In some cases, startups will be the players who will move the agenda, and in other cases, big players will need to participate as well. So you could think about these as complements to the existing programs. We're not intending to stop the big, important set of energy and science R&D programs that we have already, but we would be looking to share the leadership of these with the non-federal stakeholders to develop closer collaborations with local, state, and regional efforts. In some cases, this would make it easier to be more flexible in the way the funding is distributed, and that would have advantages as well. And then we're looking for a diversity of approaches. It could be argued that we have what we can do at the federal level and led from Washington, but so much of the experimentation that's going on is through places like Colorado and surrounding states, where the experimentation on markets, on structures, on all the ways to interact is where we can learn from that as well. So. There definitely is an opportunity to complement what we can do directly at DOE. So you say, well, okay, how's this going? And I'll preface this by saying that we always knew this was going to be a multi-year effort. We actually did very well in the competition for the President's budget. We went in with a $10.7 billion request for the science and energy programs, and you can see that just under 6 of that was mission innovation related, and the blue part of that curve is the other science and energy R&D. I don't know if I have a pointer here or not. I guess I don't. But if you look at the third column from the right, that was the President's FY17 budget request. The FY17 House and Senate marks were quite consistent. The distribution was different, but they were each at $9.7 billion. This is a consequence, really, of the previous budget agreement that gave us a good boost in 2016, but then held budgets roughly flat going into 2017. So as I said, that budget has not yet passed, so we'll see how that plays out in the final version of this. But we will keep pressing as we move forward. And one of the things that you'll see is that we, if you look at the green part of this, in the two marks, there was some reallocation of funds to the mission innovation side of things, so that part's good at least. So we have more work to do there. And I'll just close by saying that, of course, how we deploy the additional funds as they come along is equally important. We will rely on the analysis of the Quadrennial Technology Review. It's full of suggestions as ways as to areas that where there were real research opportunities. We did not attempt there to prioritize which one would get funding first. That's the exercise we're engaged in now, and we will put together an FY18 budget notional budget, since that will get submitted by the next administration, whatever that is, but we'll provide a backup for that, along with a 5-year notional plan going forward of areas where we think there's a real opportunity to do better. So I'll stop here and say that, as I think it's probably preaching to the choir in this room, but that lots of lines of evidence demonstrate climate change and that it's induced by human activities. We've actually made lots of progress. Martin Keller referred to the, and several other speakers, Governor Ritter, Governor Hickenlooper, all mentioned the fact that renewable costs have come down dramatically in the last 5 years. So we have made real progress. We need to continue to make that progress. And there's a big wide range of opportunities for innovation going forward. There's a lot that has been done, a lot to do, and we need all the tools we can get and all the players we can get on the field. So the regional efforts can really help us there. I talked in some detail about the idea of a portfolio. That still applies here. And I think that the regional innovation partnerships can play an important role in that. And thank you all for being here and for thinking about it and for applying your energies to make sure that the United States energy systems are economically competitive, give us energy security, and protect the planet at the same time. Thank you all.
Dr. Ord, could you take a couple questions?
Yeah,
from
I
the
didn't quite
audience?
fill all the time, so I guess I can, I'm happy to try to answer questions.
Great. Anybody have a question?
So I'm trying to reconcile, so you talked about the technology focus areas from the quadrennial technology review. I'm trying to understand if that's to be taken as a guidance on technology areas for the regional partnerships, because many of those seem to be region agnostic, and I also picking up that there's a desire to focus on regional needs. So how do we reconcile those two?
Yeah, so it certainly wasn't meant to be, well, it's also very high level, so it's probably too broad brush to give you any indication one way or the other. There's such a wide range of research opportunities listed in the Quadrennial Technology Review that my guess is that almost any regional partnership would not feel too constrained by what that says. We're really looking to harness the creativity of the regional partnerships to decide what makes sense to look at carefully there and to then assemble the resources, that is the intellectual capabilities to be able to go look at that sort of thing. So we're really trying to harness the creativity of lots of people around the country. So we're definitely not trying to be too prescriptive here.
Another question. We have time. Oh, here we go. This side needs more questions. Raise your hand. Yeah.
What, the left wing is not asking questions, but the right wing is?
Bob,
What I just did was to insult somebody somewhere, as depending on whether you think you're in the left wing or the right wing.
Bob McGrath, Renewable Sustainable Energy Institute here at the university. A couple of weeks ago at the Arizona Regional Summit, Deputy Secretary Liz Sherwood Randall mentioned emerging themes around grid modernization, energy and water, and manufacturing. Are those getting particular attention within the discussions?
They certainly are very important. I mean, you look at the grid modernization effort that we have underway at DOE. We have put together I mean, I think that's an area where we've underinvested for a long time, so we're obviously putting something into that. The other areas are important too. We don't mean those to be exclusive. We really, as I said in answer to the last question, those we recognize and will continue to work in our programs on those areas, but we're looking to what the regional efforts could bring to the party, so we're trying very hard not to be too prescriptive. Of course, we actually have to get some congressional authorization to go do this as well, so we have to get through that part of it. But we eventually, if we are to the point of competitions, then we'll spell out what we mean. But I think we won't try to hardwire what these do.
Does a carbon tax fit within the scope of mission innovation, or is that resting somewhere else?
A carbon tax would that would be on the revenue side of the ledger. It would, of course, influence behavior. What we're doing in terms of mission innovation is energy R&D, and so I think we would be mostly focused on the technology aspects of all of this. But how the markets work, and a carbon tax, of course, influences how those markets work, do matter as well.
Dr. Orr, I have a question about operations, and just get your perspective as a high-level DOE official. In working with national labs, we have to cover their cost share, for example. This can be very prohibitive to innovation. It can be very challenging for universities. I'm curious, do you think we're making the right investments in the DOE and by burdening the national labs with this extra challenge and not using them more wisely as a resource for our country? I'm just curious on your thoughts on that, friend.
So that's a hard question. We recognize that the way we deal with, for example, companies needs some work. So we've been working to streamline the process for CRADAs, the Cooperative Research and Development Agreements. We're kind of experimenting with a variety of ways of making both the laboratory assets available. The synchrotron road at Lawrence Berkeley is an example of that, and ways for entrepreneurs to come in, partner up with lab scientists, use the facilities, those kinds of things. There's definitely a need to do that. The national labs also provide some other things that are very important responsibilities. Some of them have to do in a big way with national security. Some of them have to do with the user facilities. And then there's a set of government federal regulations that they also have to comply with as well. We have one thing I think that it's probably not apparent to the world outside of our little group at DOE, but the Secretary has really put a lot of effort into trying to work more strategically with the national lab directors and with the labs themselves, looking at lab operations in a way to streamline. We're working very hard to streamline the whole directives process, this astonishingly complex of things that we ask the labs to do, and to share best practices. One of my jobs as the Undersecretary for Science and Energy is to try to share best practices across that. So I have 13 of the 17 national labs. And we've used that to try to streamline and use the lab planning process in a way that we'll try to do that as well. There's a lot to do there, but we do recognize that all of those things influence lab costs, and we'll continue to try to work on that.
Time for one more.
Well, there's one right down. Okay, we'll do two more. I'm the Undersecretary. I'd get to decide something.
Secretary, thank you. Bill Doe, CU Boulder. Interesting that you mentioned the not-for-profit corporation model for these. Kind of piggybacking on the last question, the model that the NMIs have used is a one-to-one cost share with industry doubling essentially the federal investment to allow these institutions and institutes to become sustainable over the long term, given the fact that the federal funding may only last for several years. But the other side of a not-for-profit is to raise funds to continue sustainability, which means you have to go out and find more money to keep the thing going aside from just the federal investment. So how will the not-for-profit corporation manage the diverse stakeholders in this from a board perspective and others so that all sectors and all industries are equally represented?
Yeah, so that's a good question. I think that's something we would, again, probably not try to hardwire, but to ask in any proposal that comes along on doing one of these things, to ask how those kinds of things would be handled. The making it a not-for-profit helps with the conflict of interest kinds of things, so there's some reason for that, but you know, I think we could listen to whether other structures make sense. There is some history in doing these kinds of things that gives an existence proof for being able to pull it off. So that's kind of the model that we went to. And then there's the last one right down here.
Thank you. Very quickly, I noticed that in talking about this, it included industry. How do you see industry participating? There's big companies can bring money to the table and do programs. If it's a small, innovative company, how do you see that participation?
You know, I think that we should be flexible enough to allow both those kinds of interactions. You know, we do various kinds of cost sharing things at DOE anyway, mostly based on what stage of development a particular effort is. At the very basic level, we don't require any cost share. If it's early stage, the industry side might put up 20% and the government side 80%. Mid-stage 50-50, and when you get to the loan programs office, it might be 80% industry and 20% federal. So varies a lot across the spectrum, and we would expect that to adjust depending on the appropriate circumstances.
And in this program itself?
Again, I think we would not necessarily hardwire that. We would like to see, I think, a set of partnerships that brought together players with a variety of capabilities and a variety of sizes. So working out a system to do that, I think, would be a benefit. All right, thank you all.